Hello class, Mr. Sutton here. Sorry I could not be there with you in person today, but I made this little video that'll help you get through your notes. You should have your bell work. If you are not finished with your bell work yet, you can go ahead and pause the video and keep working on the bell work. If you are done with the bell work, the agenda is we're going to work on Skill 2 notes, in practice solving a system of inequalities. And we're going to define an inequality and describe the difference from an equation, solve systems of two inequalities through graphing. So go ahead and turn to your notes and let's look at the vocabulary section. So this first part, an equation is a statement that two expressions are equal. Make sure you're filling these out along with me. And this is indicated by an equal sign. An inequality compares two or more values showing if one is less than, greater than, or not equal to another value. And this is indicated by less than or equal to, greater than or equal to, or the not equal to symbol. We're going to focus mostly on these four, but you will see this not equal to pop up sometimes, so it's important to include that. What does this look like? So on your notes, you should have these examples. Here is your normal equation. Looks like this. And then if we make it an inequality, if I change this equal sign to a less than sign, then all of a sudden our solutions go from, when it's the equation, our solutions is everything on this line. Now when it's a less than sign, our solution is everything below the line. And notice the line itself is dotted. That means we are not including the line as part of our solution. That is just our boundary, but the points on the line itself are not part of the solution. It's just everything below the line. So this is what this looks like. Same expression, but this is an equation, this is an inequality. That's the difference between these two. So now steps for solving systems of inequalities graphically. So when we're talking about systems of inequalities, that means two or more inequalities that we want to solve graphically. So first step, put inequalities in slope intercept form, which that is y equals mx plus b. But since these are inequalities, it's not going to be an equal sign. It's going to be an inequality symbol there, but this is the slope intercept form. Graph the lines, use a dotted or dashed line for greater than and less than. Use a solid line for less than or equal to and greater than or equal to. Step 3, shade the appropriate area for both lines. I believe on your notes it says lightly shade, and it gives you the tip to use two colors. I have a technique that I will show you where we can shade both sections and see where it overlaps, a technique that you can use one color with. But if you have two colors and want to do that, that is also acceptable. Identify the area that overlaps. This is your solution area. Step 5, check your answer by selecting a point in the solution area. Plug it in both inequalities. And make sure you get these blanks in. I forgot to take these words out and put in blanks for myself to fill them out. So make sure you identify the area that overlaps, and this is your solution area in your notes. And then for step 5, check your answer by selecting a point in the solution area, plug it into both inequalities. So let's look at this first example. Again, this is a system of inequalities. So we have two inequalities here that we want to solve. We're going to solve these graphically. First step, put inequalities into slope-intercept form. These are already in slope-intercept form. There's my slope, there's my y-intercept, slope, y-intercept. So I am ready to start graphing these. So the next step is graph the lines. I'm going to graph these one at a time. So starting with this first one here, y-intercept of -3, 1, 2, 3. I want you to graph these along with me in your notes. And then slope of 4, so rise 4, 1, 2, 3, 4, run 1. And I'm going to keep doing that. I'm going to pause the video and finish this out. So it should look something like this when you're done. You want to have as many points on here as possible, especially for ones like this. This is going to be one where it's a dotted or dashed line because there's no equal to here. So it's very important to have as many points to guide yourself as possible when drawing these dotted lines so you don't get off track. And I'm going to save my shading until I draw my other line. So other line is +3, 1, 2, 3 over y-intercept, and the slope is -2. So down 2 to the right 1, down 2 to the right 1, down 2 to the right 1, and then that would be up 2 to the left 1, up 2 to the left 1. I'm going to pause the video and keep filling out these points. You do the same. So it should look something like this when you have all your points down. And then for this one, it'll have a solid line because it has the equal to part. So I'm going to draw in a solid line here for all these points. Should look something like that. Now for the shading. So it says shade the appropriate area for both lines and identify the area that overlaps. This is where you can use two colors if you have two different colors that you can work with. My technique that I want to show you for using one color but being able to clearly see the two different shaded areas and to see where they overlap is to look at them one at a time. So this line, this y is greater than 4x minus 3, this dotted line that we have here. You can see it's a greater than symbol, so that means we want to shade above. Now you want to pick a direction that you want to shade and just draw kind of hatch marks going that direction. And just keep doing that and fill up the whole section using hatch marks going all in the same direction. So that is the shading for this line. And then for the other line, we also want to shade above because it's greater than or equal to. So for this y is greater than or equal to -2x plus 3. We're going to shade above, which would be this section here. Now I want to do hatch marks in a different direction. So I'm going to go this way instead. Should look something like this. So now we can see the shading for the two sections. I have this shading over here and then this shading over here. And we can see where they overlap is where we have the X marks. So that would be in this section right there. That is the solution area where they overlap. Okay. So, and then we identify the area that overlaps. Next step is to check your answer by selecting a point in the solution area and plug it into both. So I'd pick an easy point. And one that you're positive is in both sections. Absolutely positive. So make sure it's not like too close to your lines. Especially because this dotted line we know is not in the solution area. So I'm going to pick this point right here because it's nice and easy. It's on an axis, so that would be 0, 5, and plug it in to both inequalities and see if it is true for both. I'm going to do that now. So when I plug this point into the first inequality, I got 5 is greater than or equal to 4 multiplied by 0 minus 3. 4 times 0 is 0. 0 minus 3 is negative 3. 5 is greater than negative 3. Is that a true statement? Yes, it is. So that works for that inequality. That point is a true solution. So let's check the other one. 5 is greater than or equal to negative 2 times 0 plus 3. Negative 2 times 0 is 0 plus 3 is 3. 5 is greater than or equal to 3. Yes, that is also true. I said this was an easy point, and the reason why it's an easy point is because I have this 0 here, and when you plug in 0, it makes math pretty easy. Anything multiplied by 0 is 0. So that is how you graph a system of inequality. Next example, example 2. This one's a little different because these are not in slope-intercept form. This first inequality, x is less than or equal to negative 3. This, if you recall back to our equations, if I wrote this as an equation, x equals negative 3, this would be a vertical line where x passes through all of the x equals negative 3 points, like that. So there's nothing we can do here to get it in a true y equals mx plus b form. We'll just have to leave it like this, and then we'll graph. But the other inequality, we can get into slope-intercept form. To do that, subtract 5x on both sides. And then divide by 3 on both sides. When you do this, remember the rule for dividing by a negative number that flips the inequality. That's not the case here. We're dividing by a positive number, but you will see some examples, most likely, where you divide by a negative number and then your inequality gets flipped. So don't forget about that rule. So I got y is greater than negative 5/3 x minus 3. I'm going to go ahead and start graphing these now. This one, x is less than or equal to negative 3. So we have that point here, and then it's just going to be a vertical line. And I'm going to go ahead and draw it in. I don't need to make too many points for myself because I have the line to follow here. And this is a solid line because it's less than or equal to as the equal to portion. And then we'll talk about the shading after I have drawn both lines. So this next line, y-intercept of negative 3, slope of negative 5/3, so down 5, 1, 2, 3, 4, 5, to the right 3, 1, 2, 3. and then up 5, 1, 2, 3, 4, 5, to the left 3, 2, 3, 2, 3, 4, 5, 1, 2, 3, and that goes off the graph there. So we will be another solid line here, because that's the equal to portion. Should look something like that. So graphing, if it is less than for a vertical line, that means we shade to the left because the numbers to the left are less than the numbers to the right. So I'm going to go ahead and shade everything to the left of my vertical line using hatch marks going this way. And then for my other line, I need to shade above because it is greater than. So I'm going to shade everything above using hatch marks going a different direction. So that should look something like this. And then our overlapping region would be right here. And for this, you want to make sure and you don't have to circle the region or anything, but when you're visualizing it, you want to make sure you include the lines for both of these because these are both solid lines, so that means the lines are included in the solution. And then to check your solution, you pick a point in that region and check to make sure it fits for that it's true for both of these inequalities. All right. So you go ahead and try this next one. Pause the video, and I'm going to do it as well. And then when you are finished, you can unpause the video, and you can check to see if yours matches what I have. So go ahead and pause the video now. All right, so yours should look something like this. You should have first put them in slope-intercept form. So this inequality becomes y is greater than or equal to negative x minus 3. And then this inequality becomes y is less than or equal to negative x plus 3. When you graph those lines, they should look something like this, both solid lines. This one has a y-intercept of negative 3 and a slope of negative 1. This inequality has a y-intercept of positive 3 and a slope of negative 1. So these lines are actually parallel to each other. For this one, you shade everything above. So you'll see all of this shaded above the bottom line. And then for the upper line, the one with a positive 3 y-intercept, you shade everything below. So you see all this shading down here below. So the overlapping region is everything between the two lines and including the lines for the inequalities themselves. So a solution you might want to pick to test your answer is the origin. That's a pretty easy one. Plug in 0, 0 for both of these inequalities and check to see if you got it right. So that would be 0 is greater than or equal to negative 3. That's true. 0 is less than or equal to positive 3. Also true. All right. Discussion. Pick a partner and discuss the question. Be prepared to share and defend your answer. So the person sitting next to you, how do the types of solutions differ from a system of equations? What answers would you not expect to see from a system of inequalities? So go ahead and talk to your neighbor. Think about this, and I will give the answer in just a moment. Go ahead and pause the video. So the main difference is that for a system of equations, you have just one solution. Maybe your solution is 5, 7. Your solution is just 1 point for a system of equations. But for a system of inequalities, you have usually many different points. If I look back at the previous example, the solution is everything between these two lines and including the two lines. So there is an infinite number of solutions here in this space, right? Compared to a system of equations where we have exactly one answer, usually. All right. So that is the main difference. Excuse me. Sorry about that. So let's look at the next section, SAT problem carpentry. Ben is a carpenter who makes tables and chairs. He was recently commissioned to craft 3 custom tables, 9 matching chairs. After checking his storage room, he finds that he has 150 wooden boards and 330 nails. Following inequality represents the number of tables and chairs he can make with 150 boards. Following inequality represents the number of tables and chairs you can make with 330 boards. This should be nails, right? Nails. Does Ben have enough supplies to complete his project? Why or why not? So to solve this, we have our inequalities, and we also have some things that we can plug in. 3 T is going to equal 3 because he needs to craft 3 custom tables, and C is going to equal 9 because he needs 9 matching chairs. So what we're going to do is plug those things in. 17 multiplied by 3 plus 6 multiplied by 9 less than or equal to 150. So make sure you're following along with me as I go through this. 17 times 3 is 51. 6 times 9 is 54. Is 51 plus 54 less than 150? Yes, that is 105. 105 is less than 150. So this is true. So that means that he has enough supplies to meet that requirement. Let's see if he has enough supplies for the next part. So 334 multiplied by T is 3. Plus 27 multiplied by C is 9. It's less than or equal to 330. So 334 multiplied by 3 is 102. Plus 27 multiplied by 9 is 243. Is that less than or equal to 330? Let's see. 102 plus 243 doesn't sound good. That's going to be 345. Is that less than or equal to 330? No. 345 is greater than 330. So does Ben have enough supplies to complete his project? No. He needs more nails. Because this is the inequality for nails, right? So he is going to have to increase this number here in order to make this inequality work. So he's going to need some more nails, right? Back of the bell work, here is your skill check. Solve the system of inequalities using a graph. Identify one solution to the system. And when you've done that, go ahead and save that for next class, and I will collect it next class. Due next class as well is your Skill 1 IP. Your Skill 1 IP was due this class. I will grade it next time I see you, though. So hold on to your skill 1 IPs, and I will grade it next time I see you. Your skill 2, say, and skill 2 IP. Your skill 2 IP, which you picked up for this class, is also due next class. So I will grade both of those when I see you next, which will be next Monday. So I will see you then, because Friday is a B day. All right. So I will see you next Monday. Have a good day. I'll see you then.